Good evening and welcome to Make Programming Fun Again. My name is Karol Moroz. It is February the 11th, 2025, and you are watching my series on the C programming language. And in the past few videos, we have primarily done the so-called Kernighan and Ricci challenge. And in this challenge, I would read the book C Programming Language 2nd edition. The book was published in 1988, and it was written by Dennis Ricci and Brian Kernighan. And well, it seems like it's a great book, but it's kind of boring if you do it. I think the second and third chapter are a bit boring. And it was also reflected in the view counts on my channel and in the decreasing number of new subscriptions. So in this video, I have decided to try something else, and we are going to try and have some fun with SQLite. And I'm pretty sure most of you have already heard of SQLite. It is the most commonly used database management system in the world. And the authors estimate that there is at least 1 trillion SQLite databases in current use in the world. There is probably 100 SQLite databases on your smartphone. And there is probably one in your browser or even more. And every single Android and iOS smartphone, every single smart TV, every single computer has a SQLite database installed. And I myself also use SQLite. And I mostly use it for one-off tasks, like for example, if for a client program, for a client project, I need to generate a list. I need to quickly generate a one-off database with some statistics, or if I'm going to be recreating a database many times, I mostly use SQLite because it's very convenient in that it's operating on regular files, as opposed to PostgreSQL, which uses a server-client architecture. And for me, this is also a bit of an experiment. I am not very familiar with SQLite. I know it exists. I have used it with a Go programming language. I have not used it extensively with C. And also, I'm not an expert in C. I am learning myself. So take everything I say with a pinch of salt. Do not treat me as an expert. And most importantly, do not try this at home. And anyway, I am currently using Debian, and Debian is not famous for their for having the most recent packages in the repositories. So okay, I think this is the version shipping with Debian. Where does it come from? Which SQLite3? Okay, this is coming from Homebrew. And if I ignore the version coming from Homebrew, I think the version which comes with Debian is oh yeah, that's a lot. SQLite3 stable is 340, and I think libSQLite3 dev, yeah. So basically, the SQLite shipping with Debian is at 340. The version I have installed using Homebrew, it's 348, and I think the most recent version is 349. And therefore, if you wanted to use the latest version of SQLite on your machine, you can download the source code from the website. The best way to do it is using the amalgamation, and I'm going to show you how to use it. So firstly, we download this file. I have downloaded it already 2 times, but anyway, let's assume I have done nothing of this. So I'll just I'll just ignore all of this. I'll delete these files. SQLite amalgamation, SQLite everything. What do we have? I remove the test. I remove the libraries I've built, and I remove the libsqlite3a. Okay, so now I copy the SQLite amalgamation file into this directory. I unzip it, and I copy the SQLite3 C and H into this directory. Okay, so I end up with I'm going to delete these files. Okay, and now I have a SQLite3.c and SQLite3.h, and what we need to do is we need to compile the SQLite3.c as an object. So this basically means we are going to compile it without linking. If we do it with GCC, I think the way is using. I'm going to try it with GCC first, and then we can try it with clang. So with GCC -c means compile only, if I'm not mistaken. SQLite3.c, we output to SQLite3.o. This is going to take a few seconds because this file is big. And now we end up with a SQLite3.o. Okay, it says it's an LSB relocatable, whatever this means. And now we can combine it with, we can make it into a static library. So 3.a SQLite3.o. I think it's like this, right? So now I don't know what this means. I just found it like so. Honestly, I asked ChatGPT, but it works. So yeah, who cares? So now I have here here I've got the a simple test program, which basically just prints a constant defined in SQLite3. I think in SQLite3 it is defined as an external variable, so it should come directly from the library itself. So I can compile it I can compile this file with the library we have just compiled into a file called test. And now if I run test, it shows me that SQLite3 is at 349. Okay. So now we can try and do the same thing with clang. Clang-c SQLite3.o. SQLite3.c all SQLite3.o. Okay, it also seems to work. And now we do the same thing. We combine it into an archive. And now if we try, what would happen if we try to build it with? Okay, it also seems that it still works even if we compiled the library with clang and the program with C. What if we try to do the same thing with clang? Test still works. So this is great. And now we can probably we should probably ignore some of these things, but maybe we can try to combine those things we've done into a makefile. Okay, so let's write a makefile, and here I'm going to say yeah, I'm not an expert at makefiles, so I'm just going to say cc-c SQLite3.c all SQLite3.o arrcs libsac SQLite3.a SQLite3.o, and default is going to depend on SQLite, and then we say cc test.c SQLite lib SQLite3.a all test. So now if you run make, it should try to compile the yes. So now if you run make, it should compile the SQLite library, and it should try to link it with our program. So if we try to rerun this again, it will okay, yeah, for some reason it okay, well, what if I did this, basically tell it that it will make work. Okay, yeah, so basically it's going to compile both every time. Okay, so basically I'm going to remove the dependency for now. So but wait, what? No rule. Okay, what if I say, what if I rename it to test, make test? Okay, yes. So test works. If I delete the binary, it doesn't exist. If I rebuild it, it works. So now we have a pre-compiled SQLite3 library. So we do not have to wait for the dependency to compile every time we want to build a program. And now I'm going to define a git ignore file. Git ignore. I'm going to ignore everything. I'm going to leave SQLite C. I'm going to leave SQLite O, SQLite H. I'm going to leave any C file and any H file, basically. So now we now end up with a, and also I'm going to ignore makefile, and I'm going to unignore git ignore, and I'm going to unignore makefiles, right? So now we end up with 4 new files, and I'm going to commit so we can work with a clear okay. What is this? Okay, so this file is kind of getting ignored. So we could probably write I'm using this file. I'm using this program called Jujitsu, and it basically denied committing the SQLite.c file. So maybe maybe later on we can write a script that will download the amalgamation if it doesn't exist. Anyway, let's try and have some more fun with SQLite. So I'm going to read some of the documentation, and I think some of the readers may hate me for this white mode, so I'm just quickly going to install Dark Reader for Chromium. Okay, so now the SQLite documentation is in a dark mode, and I'm going to make it a bit bigger so it's easier to read for you. Great. So this article is called SQLite in 5 minutes or less, and we can just assume it is a good introduction to the topic. So download the code. We have the code. Okay. Create a new database using the command line interface. The command line interface, or CLI, is a simple command line program that accepts SQL input text and passes it through to the SQLite database engine core to be executed. The name of the CLI program is SQLite3 or SQLite3.exe on Windows. Use this CLI for manual interactions with the database. So I do have a SQLite3 shell, but it's the one installed by Homebrew. We could also compile it from the source code, but it mostly doesn't matter. If you are on Windows, I think the CLI may have limited functionality in terms of some third-party libraries. But otherwise, even on Windows, it should work more or less the same. Okay, we have the command line interface, and let's say at a shell or DOS prompt, enter SQLite3 test.db. This will create a new database named testdb. You can use a different name if you like. Okay, SQLite3 test.db. Okay, did it create a testdb? No, it did not. So in order to store something in the database, let's say we just, because what I wanted to showcase was kind of like a cart. I have once done a simple program that would basically show like an ordering interface in the console. So let's say we could basically just make it and write a script to initialize the database, right? So let's say we create table products ID, which is going to be integer primary key. We could use UUIDs, but we would have to have a generator. So for now, let's just drop table products, create table products with ID integer primary key, title, which is text, not null, a slug, which is going to be text, not null, unique, and maybe a description. Text, the base price, which is going to be a numeric, not null, default 00, and inserted at, let me see, SQLite3 Unix timestamp. Current timestamp, no. Okay, yes, there is a new function called Unix epoch. Let me see if it actually works. Select Unix epoch. Okay, yes, this works. So inserted at is going to be a big int. This should be a 64-bit integer, and not null, default Unix epoch, and we are going to do the same for an updated at. Okay, and then we insert some products. Title, slug, description, base price, values. I'm going to use examples from, let's say, McDonald's. So a hamburger is going to be a bun with a patty inside, also known as steamed ham. Okay, and the base price, it could be $42, whatever. Maybe if you live in Taiwan, it's actually going to be 42 Taiwan dollars. And now we could execute this this script. No such table products. Okay, drop table if exists products. Okay, so now if we open the test database, we can fetch the products from the products database. So we got the this is the data we have entered into the database. So now what I would like to try to do is I would like to connect to this data, to open this database using a C program, and I would like to select this data so we could display it programmatically. And we already have an existing database with some data. We have created it using a SQL script. And now I'm going to write a program to connect to the database. And what does this callback say? Okay, anyway, I'm going to put it on one side, and I'm going to open the editor on the other side. And in the test.c, I'm going to, so let's say SQLite3 pointer to a SQLite3 database. What is this Z error message? Int RC. I don't really know what these variables currently mean, but we may soon find out. Okay, I think this Z error message variable will be storing an error message from the database. Okay, and this RC, okay, I think it means return code or something. Should be SQLite okay on correct execution. Okay, great. So now let's try to connect to the database, as in open the database. So RC equals SQLite3 open. And should we use v2 or open? Let me see. Okay, we don't have an entry, so I'm going to look into the documentation. Introduction. What do we have? We have SQLite open. What does it say? The file name argument is interpreted as UTF-8 for SQLite open and SQLite3 open v2, and as UTF-16 in the native byte order for SQLite3 open 16. A database connection handle is usually returned in ppdb, even if an error occurs. The only exception is that if SQLite is unable to allocate memory to hold the SQLite3 object, a null will be written into ppdb instead of a pointer to the SQLite3 object. If a database is opened and or created successfully, then SQLite OK is returned. Otherwise, an error code is returned. The SQLite3 error message or SQLite3 error message 16 routines can be used to obtain an English language description of the error following a failure of any of the SQLite3 open routines. The SQLite3 Open v2 interface works like SQLite3 Open, except that it accepts 2 additional parameters for additional control over the new database connection. The flags parameter to SQLite3 Open v2 must include at a minimum one of the following 3 tag combinations. Read write, okay. No mutex. Okay, I don't think we need to worry about this at the moment. So let's see. We are pointing to a file name which is going to be test.db, and we are going to point it to our DB thing, right? So if rc is not equal to SQLite OK, then we print to standard error failed to open database, and we're going to print an error message which can be obtained using SQLite3 error message, right? And it has to be like so. Exit 1. Okay, yeah, I think this call comes from a standard library. H. Okay. Now let's see if this works. What? Yeah. Okay. Can I make it work? Okay, well, apparently it works, but we cannot have no way to check if this actually we have no output. Okay, we need to. Okay, also if for some reason we cannot open the database, we should also close it. Okay, so SQLite3 close db. Okay, and now we can prepare we can execute a query, right? So db, we can try to select 2 plus 2. Okay, yeah, so for now let's just do a simple can we put a null here? Okay, yes we can. And we a pointer to the error message, 2 of your arguments to function call. Callback. Okay. What are the arguments called actually? Const char squeal, callback, a pointer, whatever, and a pointer to the error message. So if rc is not equal to SQLite OK, we print an error message, failed to execute query, and we can basically output the error message, right? SQLite3 free the error message, and then at the end with SQLite3 close db return 0. Okay, let's see if this works. Okay, it probably still works, but we just aren't doing anything with this result. So let's say we have a pointer variable for a result, and result equals okay, what if I wanted to get if I wanted to make a statement, right? Opening a new database? No. I'm going to look quickly for the. Okay, I think we can get we can do this with a prepared statement, right? So, is there an example? Okay, how about some other tutorial, right? So, programming interfaces, introduction to the C++ API. Okay. Other interfaces. Okay. Okay, what can you get from the exec? The SQLite3 exec interface is a convenience wrapper around SQLite prepare v2, SQLite step, and SQLite finalize, that allows an application to run multiple statements of SQL without having to use a lot of C code. The SQLite3 exec interface runs 0 or more UTF-8 encoded, semicolon, space, separate SQL statements passed into its second argument in the context of a database connection passed in as its first argument. If a callback function of the third argument to SQLite3 exec is not null, then it is invoked for each result row coming out of the evaluated SQL statements. Okay. Okay, but how can we get the example, the results? Okay. Okay, I think we want something else. Let's see. To execute an SQL statement, it must first be compiled into a bytecode program using one of these routines. Or, in other words, these routines are constructors for the prepared statement object. The preferred routine to use is SQLite3 prepare v2. The SQLite prepare interface is legacy and should be avoided. SQLite prepare v3 has an extra prep flags option that is used for special purposes. I mean, if you're taking prep, then you're probably using it for special purposes. The use of UTF-8 interfaces is preferred, as SQLite currently does all parsing using UTF-8. The UTF-16 interfaces are provided as a convenience. The UTF-16 interfaces work by converting the input text into UTF-8, then invoking the corresponding UTF-8 interface. The first argument DB is a database connection obtained from a prior successful call to SQLite Open, SQLite Open v2, or SQLite Open 16. The database connection must not have been closed. The second argument, zSQL, is the statement to be compiled, encoded as either UTF-8 or UTF-16. The SQLite3 prepare, SQLite prepare v2, and SQLite3 prepare v3 interfaces use UTF-8 and SQLite3 prepare 16, SQLite3 prepare 16 v2, and SQLite3 prepare 16 v3 use UTF-16. If the end byte argument is negative, then ZSQL is read up to the first 0 terminator. If end byte is positive, then it is the maximum number of bytes read from ZSQL. When end byte, okay, yes, so we know what we can parse. Instead of this, we can try to prepare it, right? So I think it also what does it return? Okay, where does it? Okay, SQLite3 statement, and then RC equals SQLite3 prepare v2 db select 2 plus 2, and we're going to read pass -1 in here so that it reads until the null terminator. Then we pass a pointer to the statement, and what does pointer to unused portion of ZSQL? I think we can try to just pass null in here, and if busy-tail is not null, yeah, so it can be null. PP statement is left pointing to a compiled prepared statement that can be executed using a SQLite3 step. If there is an error, PP statement is set to null. If the input text contains no SQL, if the input is an empty string or a comment, then PP statement is set to null. The calling procedure is responsible for deleting the compiled SQL statement using SQLite3 finalize after it has finished with it. PP statement may not be null. So basically, we need to finalize it. Statement, okay. And now, if RC is not SQLite, okay, then fprintf standard error failed to prepare statement. An error code is returned. Can we get an error message somehow? Okay. Yeah, let's just print the error code. And we close the database and exit with a non-zero exit code. Okay, then we have SQLite step. And after a prepared statement has been prepared using any of SQLite3 prepare v2, this function must be called one or more times to evaluate the statement. The details of the behavior of the SQLite3 step interface depend on whether the statement was prepared using the newer VX interfaces or the older legacy interfaces SQLite3 prepare and SQLite3 prepare 16. The use of a new VX interface is recommended for new applications, but the legacy interface will continue to be supported. In the legacy interface, the return value will be either SQLite busy, SQLite done, SQLite row, SQLite error, or SQLite misuse. With the v2 interface, any of the other result codes or extended result codes might be returned as well. SQLite busy means that the database engine was enabled to acquire the database logs it needs to do its job. If a statement is a commit or occurs outside of an explicit transaction, then you can retry the statement. If a statement is not a commit and occurs within an explicit transaction, then you should roll back the transaction before continuing. SQLite done means that the statement has finished executing successfully. SQLite3 step should not be called again on this virtual machine without first calling SQLite3 reset to reset the virtual machine back to its initial state. If a SQL statement being executed returns any data, then SQLite row is returned each time a new row of data is ready for processing by the caller. The values may be accessed using the column access functions. Okay, so we know this is going to return one row, so we can say while, but anyway, while rc equals SQLite3 step statement equals SQLite3 row, SQLite row, I think. Result equals SQLite3, and then we get the values. Column access functions, okay. SQLite3 column int 64, or int in this case, int column int, and we are pointing to the result. Wait, what statement, and what does the second these okay, I'm going to quickly read what these columns do. What does iCall say? These routines return information about a single column of the current result row of a query. In every case, the first argument is a pointer to the prepared statement that is being evaluated, and the second argument is the index of a column for which information should be returned. The leftmost column of the result set has the index 0. The number of columns in the result can be determined using SQLite3 column count. Okay, let's say. Okay, and printf the result. Let's see if this works. Yes, so this is very underwhelming, but we have actually fetched we have actually made a computation using SQL in a SQLite database. Okay, don't laugh. Don't laugh. Anyway, this is we are having some progress. Let me commit and okay, so now we can try to actually fetch some products. Okay, so I'm going to start splitting this into routines. So yeah, I'm going to write a function that returns that connects to the database, and it's going to take a string const char connection string. Okay, and I'm going to write okay, and I'm going to move this code in here. So int rc equals SQLite3 open path. Okay, SQLite3 db. Okay, path and db. So I'm basically, what does it say? Is of okay, this has to be called connection string because this is the argument we are passing. And now, if the result is not SQLite OK, then we exit, and then we return the pointer. So in here we can say db equals connect to test db, and this way we have kind of refactored the code. So, but it still returns the correct result. Okay, and now we can write a, and I'm going to rename it to must connect. Okay, and I'm going to write a function that returns a pointer to that will definitely prepare a statement. So it's going to take a pointer to the database and a SQLite statement, and I'm going to define this function here. I'm going to copy the definition, and okay, I'm going to, let's say int rc equals SQLite prepare v2, then the I'm going to pass the parameter, and if the result is not SQLite OK, then we print an error message, we close the database. Do you also have to free it? I'm not sure. And we return this statement. Okay, so now we can say must prepare db and select 2+2. Okay, great. So now we can step it like this. What if we use a different, what if we say a Unix timestamp? Was this a, oh, it's Unix epoch. And it's a function, okay? And it's probably going to be an int64. So I'm going to define it as uint64.t underscore t result. And I'm going to call it here. So Unix epoch, like this. And the result is going to be colon int64. Okay, and stdint.h. Okay, format specifies that int, and this is a long. Okay, let's see. We make it, and it prints a Unix timestamp. Perfect. So, yeah, I'm going to commit again. And preparing statements. Okay, great. So now, what I'm going to do, I'm going to try to fetch the product data from the database, and then we can try to convert it to some sort of a menu where you can place orders, and then I think in the next videos, if my viewers like this series, we are going to expand on this program and we could try to do some more exciting things, like we could try to store UUIDs, and we are going to need to generate those UUIDs somehow. And also, let's say we wanted to actually return an array of products, then we are going to need some way to grow this array. And this is not handled by the standard library, so we were going to need to implement a vector, or like a growing like a dynamic array. And this, I think this is also going to be quite exciting. Anyway, we now have this Unix epoch query. So let's say we want to define a struct for a product. So in the init.sql, we can say the product has an ID which is an integer. It has a title. It has a slug. It has a description. And what does it have? It also has a base price, which I think it may try to return it as a double. Okay, yeah, let's just do it like this: double base price, and then inserted at is I think it's a time. Does time t stand for? Okay, it's a long. So I'm just going to do it like this: inserted at and time t updated at. So now I would like to try and fetch this this product. So I'm going to say select ID, title, description, title, slug, description. What do we have? Base price. What else do we have? Inserted at, updated at, from products. And for now, let's just say limit 1. So now, if I try to, okay, it should say std, okay, yeah. So now it just prints 1, because we are still only scanning the first column of the result, and this result is going to be the ID of the product. So let's say okay, we are fetching all of these. So now you can say product, and let's say, what does the result say? Okay, we can say that the product's ID equals SQLite column int, like so. You can say that the product's description equals SQLite3 column. Is it bytes? I think it's text. It returns chars. Okay. Statement. And okay, let's say title first. And it's the first column. Okay. And this should be uint 8t uint 80, uint 80. Okay. And what does it say here? Const unsigned chart T discards qualifiers. Okay, we need to cast it so the compiler knows that we are doing this explicitly. So now we can print the ID. What did it specify? No, why does it complain? Oh, it's the product's ID. And we print the ID and then we can print the title. So product title. And then we can, is this result used anywhere? No, it's not. So let's just discard it. And now we are printing data from the database. This is amazing. Let's go a step further. Product base price equals SQLite3 column, and I think it's a double statement, and this is 1, 2, 0, 1, 2, 3, 4. And let's print the price. I'm kind of inclined to use a Unicode hyphen. Let's see if it works. It's a Unicode 2014. It's an M dash. And now let's say the price should be 0.0f product base price. Compile it, and it does print. And we can also specify it costs, its price. Okay, we could we could go on further, but I think I'm getting the gist of this thing, and I think you're getting a gist too. Please let me know if you enjoy exploring the library just as I do. I can happily do a few more practical videos about this topic. I also think this is more practical and will teach you more than just reading the Kernighan and Ritchie book. And yeah, obviously SQLite is very practical, and even if you just learn it in C, it will also help you use it in different different projects, like using Swift in an iOS application, or you can use it even for web development, or you could use it for some scripts in Go or Python or JavaScript. Like, the possibilities are endless, and the licensing is amazing. So if you have enjoyed this video, please like and subscribe. If you did not enjoy this video, then please tell all your friends you hated it, and give them a chance to come and hate it as well. And I hope you learned something, and I will see you in the next video.